Ever wondered how to split a single network into multiple smaller ones? The secret lies in subnetting. In this video, we'll break down how subnetting works, how to calculate subnet masks, and why it's crucial for efficient network design. Whether you're studying for a certification or just curious about networking, this is your ultimate guide to mastering subnetting. Ready to optimize your network? Let's dive in.
We saw that with an address class C, we can have networks of 254 hosts. In this course, we will see that it is possible to divide a network, that is to say, cut it in two. This process is known under the name of subnetting. As an example, we will take an address class C, and we will see how it works in binary. To start, we need to find the new subnet mask. We will not touch the first 3 bytes, and we will borrow 1 bit in the host's part. If we now convert our binary to decimal, this gives us 128. Our new subnet mask is therefore 255.255.255.128. In the last byte, we have 7 bits left for our hosts. If we calculate all of its bits, this gives us a total of 127 plus the 0 that must not be forgotten, i.e. a total of 128 IP. And here is our Class C network, which has been divided into 2 subnets with a size of 128 IP each. But it is not finished. We now have to determine the network and broadcast addresses of our 2 subnets. For that, we will play again with the last 7 bits. To find the network, it must pass all bits to 0 after the separation, after the 25th byte. The network address of the first subnet is therefore 192.168.10. To find the broadcast address, all the bits must be set to 1, always after separation. The broadcast address is therefore 192.168.1.127. In this 128 IP subnet, if we remove the network and broadcast address that we cannot use, we are left with 126 IP that we can assign to hosts. These are the IPs from 192.168.1.1 to 126. Now let's move on to the second subnet. As the first subnet ended at 127, we will continue with the following IP, the 128. If we change all of the bits to 0 after the separation, this gives us the network address as the 192.168.1.128. And if we change all the bits to 1, we find as the broadcast address the 192.168.1.255. We can therefore use the IP addresses from 129 to 254, which come from the network 192.168.1.128. In conclusion, by borrowing 1 bit of hosts, it is possible to create 2 subnets. For each bit we borrow, it is possible to double the number of subnets. That is, if we borrow 2 host bits, then we can create 4 subnets. If we borrow 3, then it will be 8 subnets, and so on. If you are a bit allergic to binaries, then I have good news. In the rest of the course, we will see how to simply make subnets by working only in decimal.